So the slides are pretty packed. They will be online, so you don't have to read or just follow the story. I will teach a story. So I'm not working for any company. This is my personal game research that I did at home. It took 4 years of madness. So the problem is I like intelligent stuff. I like finding what is not in paper or not common. So this is what I wanted to do. Basically, I don't trust anything, not even the code that I prepare or even the tools that I use, so I consider everything malicious. So I have to find that is what is malicious, and I have to contradict myself. This is the point. Problem, I need to analyze normal and encrypted communication. I need to analyze files. I need to analyze patterns and strings. And I don't want to spend a lot of time or money because I want to do it with a normal computer. So the setup that you will see is at home, total expense is around 3,000 euros. Target is find what I don't know I can find. I work with 3 guys, one software developer, very good in secure coding, and a lawyer, because for this stuff you need a lawyer. Why? Because when you go work with intelligent stuff, if you do it properly, it's 90% you find what you don't want to find, and you have no idea what is the implication of what you found. So problem, 3 big theoretical problem. I have to find information, so data discovery takes a lot of time. I want a platform. I don't want to do it manually. Second, automation. I want a set of specific tasks and specific agent to do the stuff. And third, profiling. I have to be able to choose what I like, not what the system is able to give me. That is very complicated. Then technical problem. It's a long list. Basically, after 1 year of playing with any possible tool, segmentation fault, error, crash, whatever, I say, okay, I will create the tool by myself. I try to use Python. Even Python will go in segmentation fault. So I say, okay, I will build the library completely. So together with my friend, we rebuilt half of the low-level library in Python. So the OS, the system, call with the network, call with a protocol handlers. Why? Because I work with dangerous stuff, and 90% of the tool are only supposed to receive good protocol stuff. For me, it's the opposite. So I tried a lot, but this was the only feasible way. So what we did, basically, we rebuilt all the protocol handler and the file handler to be secure. And we didn't want any attack, because I don't want people to see that I'm attacking their server. Everything has to be completely hidden. I have to do it passively, and you don't have to see me. Otherwise, it's not intelligence. It's like taking a car and breaking inside a bank with a car. That is very difficult. So a little bit of history for some of that want to play the same stuff. 4 years, absolute madness for the code and the test. Untold amount of segmentation fault, error, and crash. I corrupted my system like 10 times. But at the end, we did something. And we create a system where you can profile rules or profile the traffic with kind of human syntax. So I want all the system in this part of this country that are answering with this kind of packet, and they have this option in the TCP flag, but not the other option. This is not almost impossible. It's very difficult in normal system. We had to build even the storage system. This is my lab at home. It's a little bit complicated, but it's my home. So if someone wants to do it, this is a schema. My girlfriend hates me for that, but you know. This is what we did to set up, in short words. I decided I am a normal user. I don't want to look in places where I know there are bad stuff. I want to look at normal place, normal system, normal website, collect everything. It means full packet capture that arrive at my house. So I subscribe to a lot of mailing lists. I subscribe to a lot of RSS feed. I went to the website of Alexa. I scripted Firefox to go in the website, browse it, save everything. So there is no attack, no crawling, no robot, zero, and store it. The problem is the amount of data is 19 gigabytes a day, more or less. Normal firewall are not working, so I have to use pfSense with a €80 machine. It's Pentium 1 core. A little bit tweaked because I had around 100,000 IP states a second to do stuff. Normal firewall collapse. This is normal problem for firewall, attack on the firewall. The traffic is here. It's around 27 terabyte a month. My provider hates me. They will know, but it will test. So test case. This is a test case. I want to find information correlating mailing list and website. What can I find? So I made a little test between March and June of this year. Analyze temporal flow pattern. I don't go into detail. If someone wants information, ask me. So temporal pattern, spatial pattern. Because we have the libraries that can find every information in every part of the protocol, we analyze protocol anomalies. Actually, I have 0% protocol compliance around the stuff. So, data anomalies, a lot. Data anomalies. String anomalies. Python was crashing a lot for string anomalies. Kernel dump. Windows, the same. I'm trying to think how to post something like 200 problem to around 20 tools. Takes time. I will do it when and if I can. Then we have to correlate the stuff. Now, as I said before, I have to build my own storage system with the guy that is helping me. So what we have created, something that is hash table, so multi-hash table, plus something to store the key, so key value storage, in a distributed environment in one machine. And then we analyze for virus, for malware, and for entropy or patterns. Then the duplication at every level, the duplication of string, the duplication of file, the duplication of log, everything. So this is the first week. We start with 12 gigabytes of deduplicated stuff. We receive 14 gigabytes. But at the end of the week, we receive 90 gigabytes, and the size of the data is 24 gigabytes. Because we deduplicate everything. And we did it was full packet capture. It means for every stream around 1,000 indicator. To say business indicator, whatever. Information. 1,000 for each stream. Around 70 terabytes in total. Deduplicated, it's down to around 12. The most expensive part was the storage to buy the hard drive disk. Test for the antivirus. I collected the stuff for 4 months. I didn't touch it. Then I took the definition of free antivirus, Bitdefender. You will check when the slide will be online. What we found, they were discovering and files from the stuff that I downloaded. I just put the top 10, even for Clamor. At the end of 4 months, it's around 42,000 infected files. It means that over time, we went from 0% detection to 10%, 20%, and I think it's very similar to the statistics that the guy was showing in the first presentation. Maximum, I arrived to 40% of detection for the antivirus. Which kind of stuff? Statistic for the meme type. Basically, it's text file, but with infected code inside. And even the entropy distribution, because I have all the possible indicator. Entropy distribution is completely strange. It's from real traffic. Then, second test. I know that this stuff, they are not coming from normal stuff, and I know because I detected with the virus, with antivirus, and with the signatures that are from bot. So, where is this stuff? Because I have all the information, I have all the correlation, I have all the connection, we connected the pieces, we connected the bits, we analyze all the strings, we analyze all the traffic, using the information of each week. For example, geolocation, you have to update every week. Who is the information every week, because otherwise you have a percentage of error that it's higher than the percentage of good results. So when I went to dig through the mountain of information, because we have one piece of information for each object, it was pretty fast. In less than 20 minutes in my home machine, 500 euro. This was autonomous system. Now there is something that I only heard here from one guy that was saying something similar. I found hidden autonomous systems, strange stuff. They don't disclose themselves. They don't say anything, but they're there. There are no information, but the autonomous system is publishing stuff. These are by country of how much traffic from which country arrive at my home. And the statistic for the registrar. This is what happened. This is an image that we built using the information that we have. Who is sending bad stuff to my house? People from here. Then, how many people from where? Then we build this one, so maybe it's easier to find who sends stuff to my house. And this is important because I'm not attacking anything, I'm not crawling anything, I'm not exposing anything. You don't see me, you cannot see me, and you will not see me. But I am checking the stuff, and I can have all the possible information that one can imagine about all the information that arrived to me, because I didn't ask for them, they send it to me. Now, one-level correlation is okay. Two-level correlation, you need a lawyer. Three-level, you need more than one lawyer. Why? Because you can find pretty dangerous stuff, and something that most of the time is not public, and there is no way for you to publish it, because there is no solution. So that is kind of an ethical problem, like the hidden registrar. So how can be autonomous system in operation not sending information or not registering anything? I don't know. Nice example. I have my own DNS, my own infrastructure at home. Strange, but I have it. And randomly, I was not able to arrive to the website of BotConf. And I've seen random traffic arriving to my DNS recursion at home, and it was perfectly okay, but I was not able to reach the website of the conference. Why? I discovered that something in 3 network was sending malformed packet from the DNS with something attached at the end. I found bot traffic that is not recorded as bot traffic with piece of information at the Ethernet frame level. I found ICMP packet, ACK packet, reset packet with stuff in the Ethernet level encoded in base 64. Something is there. I didn't check it because I didn't have time. A lot of stuff, a lot of SSL traffic, strange bot scanning with SSL with a custom protocol, DLP protocol, DLP3, DL3 stuff from my system. I have no idea what it sent it. I know that it's from my test environment, and I recorded everything because I have the full packet. Because usually you don't have the decoder for the traffic, so it will be completely under your radar. I built system for 15 years. I never thought about making a protocol analyzer for the traffic. So that is something that I will look forward. These are my contacts. If anyone is interested, again, it's very research project. We are building the package in Python. I start to get in touch with a guy at OWASP to publish the Python package as a package for security, because we build half of the low-level library in Python specifically for security stuff. And now we have to make the interface, because now it's useful only for me and another guy. So it will take a little bit of time, but if someone is interested, contact me. I have my card, you give me a card, whatever. And as soon as I have something that is useful by human, then I will get in touch and we will try to see if something can be done. Finish?
Okay, who has questions for Enrico? That's interesting.
Hello again.
Just two things. Could you flash up the slide with your lab environment description? Thanks. And you're going to be posting these online later?
Yes, they will post it online.
Super. Thanks.
Yeah.
Great presentation.
Thanks. Sorry. You can buy the stuff in eBay for around 600 euro. In US it's cheaper. Some of the stuff you don't find it in Europe. At least I didn't find looking for 6 months, so maybe, yeah.
Hiya.
Yeah.
Gavin from Semantic. So you mentioned that you rewrote a large number of the Python libraries.
Yes, yes.
Do you have any evidence that those libraries were not correctly parsing protocols, which led you to then rewrite them?
Yes, actually it's in the code. It seems like, for example, if you use kind of tools for analyzing X files, like XXScan, PID, all this stuff, everything in Python is a string. Now, depending on what is a string, Python, even if it's detecting the information as an exception, it parses the string anyway. How I found it? Another time, absolute madness. Because I use this tool to analyze the executable, and with XXScan, we had a detection of around 10,000 executable pieces. As soon as we use our code to analyze the same stuff, to check the same information, we have 50% different result with the MD5. I had a chat with Guido and Alex, the guy of Python, at the conference, and they say the problem is that the library, as any language, are made to be used, not to put check, balances, control, and verification. So, for example, in the socket library, there are stuff that you have like a timeout. You have a timeout that if you receive an empty answer from a server, it will go in loop forever. Now, how can you solve it? You have to recheck all the library to rebuild all the logic, because you don't expect good traffic. You have to expect bad traffic. So it's not an exception anymore, it's a feature of the code. And you cannot do it in the library in Python at the moment, because everything is based to, as a normal language, you expect to know what you're doing, and you build code. But I have to do something that I don't know what is coming to me, and I have to build something to handle always what I know that is not compliant. It's completely reverse approach. And we try for 6 months to change the libraries, but then we change one piece of the libraries, and we have to change another piece, then we have to change another piece.
Okay, yeah. Okay, cheers.
I just have 2 questions.
Yes.
The first one, will you share the cap files?
Legally, I can't.
Okay. And the second question, did you try to evaluate the TCP reassembly of Suricata, Snort, and Bro?
Actually, I tried to use the normal installation for all these 3. My machine were exploding, creating gigabyte and gigabyte of log. So I had to recompile the IDS to only use text log, so only unified log, and then use a parser for a unified log, because a normal parser, if receive rubbish, it discards the rubbish. What is broken, what is corrupted, it's discarded, but I wanted it.
So you don't rely on the TCP reassembly of the intrusion detection system?
I check even that part, and they were discovering, and because I found the problem in the detection, the part in TCP dump, it's a full packet capture of the traffic, and then I compare the traffic with the detection. Okay. It's around between Suricata and Snort, it's 15% of difference. Bro and Snort, it's 8%. Suricata and Bro, it's around 20% for my traffic. It can be completely different because I use the custom modification of the stuff. But yes, I've seen difference in the detection of the protocol.
Thank you.
Yeah.
Hi, Ulrich von Onsick.
Yeah.
What were the legal constraints in this step that you constantly consider? What were the most obvious legal constraints and the less obvious?
Most obvious, I receive traffic from people that don't know they're sending traffic to me. So if I store the traffic, under the European law, if I use correlation on the traffic and I can pinpoint something, that is illegal. If I pinpoint something, then it's my responsibility. But to don't pinpoint the traffic, you have to build a whole system below the detection to clean the traffic. It means you have to take the information in memory, you don't know that it's there, and you have to be sure that it's not written because you cannot see it. The system cannot make more than one level of correlation. Otherwise, European law is illegal. The less obvious, SSL. SSL traffic is encrypted. With what we did, we can see problem in the SSL creation of various protocols. If you are tampering SSL traffic of people that are sending to you, if it's a company, you enter in their domain. So if the SSL traffic is trusted communication, I am able to break the SSL because they made a mistake. Once I'm inside the channel, I'm using their infrastructure, not mine. And that is illegal.
But you do everything under your own private environment.
Yes,
so everything's being sent into your private environment.
Yes, but because it's two-way for SSL, if it touches them, then I'm liable for any damage that can be done because I'm entering their digital domain. This was one of the most difficult parts. Yeah.
Last question? No? Really? Yeah.
Trey, with Splunk. Yeah. On that last point there, what was the case law like? I know you were collaborating with a lawyer, but
yes.
This is not an intuitive interpretation, at least to me, and maybe I'm just hungover. Can you say something about the legal frame underpinning of this?
And under the law, when you're using, for example, you download a file from a company, the file is property of the company even if it's freely accessible. So you are using the infrastructure of the company, you use the resources of the company, and you enter in their domain. Now, if you use it and you don't do anything, it's okay. At least this is what everyone told me. So maybe I'm saying rubbish, but this is what everyone told me. But if you, again, put the correlation between that file and who else has that file, what are the metadata on that file? If you connect these three pieces, you have who has the file, who creates the file, who is using the file. That is personal identification. And that is illegal. So you can have it, store it, but you cannot cross-reference the information. It's why if you have IP domain, IP autonomous system, file metadata, it's okay. File metadata autonomous system, problem. Because you connect pieces, that is only in Europe. You go somewhere else, it's perfectly liable, it's perfectly fine. It's kind of problematic. And this is research, so it's legal, as far as understood, in France. You cannot do it because this is automated. You cannot do it in UK or in Germany. That is another problem. If you do it, you're a terrorist, so be careful. Yeah, we can talk later.
He's getting arrested later. But
yeah, I hope not.
Okay, thank you, Enrico.